Okay, so I think we're broadcasting right now. Hello, everyone. Now I see my Google Assistant running in the background. Sorry about that. So hello, everyone. Welcome to the next episode of Google Cloud Developer Group Poland. So today we have special guest who will be talking about Cloud Run. Very interesting and insightful presentation today, and then we will have some labs. So let me just share my screen quickly and show you what we actually have today in the plan. Do you guys see my screen? Jarek?
Yes, we can.
Okay, awesome. So we have Wietse today with us, who's an author of the book Building Serverless Application with Google Cloud Run. Really exciting. So we will have a walkthrough how Cloud Run works and how this can be used for running, well, let's call it serverless applications. I'm really excited for this session. We're going to have a lecture first, and then we will switch into a meet request that I will send in a bit to all of you. So we can switch to the lab and actually see how Cloud Run is working in practice. Okay, and important stuff, we'll be giving away 3 hard copies of the Professional Cloud Architect Google Cloud Certification Guide written by myself and Brian Gerard. And actually, Jarek was reviewing this, so the quality of the book should be good. How are you getting those? So we would like you to put some info on LinkedIn that you're with us and tag myself, Jarek, and Wietse, so that we know you're with us. And we will be looking at those posts, and I'll inform you by the end of this presentation which post will be getting those 3 copies of the books. Okay, very important thing, the new beta exam is coming, so I had the opportunity to participate in it, and our book will be updated for this as well, so stay tuned. You still can use our book for passing the exam until the new GA of the beta is coming, but be aware that there will be a new version, and we're working on this to update you all, guys. Okay, so now let's switch to the presentation. Wietse, you're ready?
Yes.
Let me just change the, I need to switch who's actually in the presentation. We should have you there. You're also presenting, adding this to stream. I'll just remove myself and Jarek, and the floor
is mine. Excellent. Well, thank you for having me. I'm super excited to give another presentation on Cloud Run. But before I head into the talk, I want to explain Google Cloud Run to you in one diagram and tell you why I, as a software engineer, am so excited about it. Because the Cloud Run developer workflow is a straightforward 3-step process. First, you write your application using your favorite programming language. And this application should start an HTTP server. Second, you build and package your application into a container image. And finally, you deploy the container image to Cloud Run. And once you've deployed your container image, you get a unique HTTPS endpoint back, which means you don't have to manage HTTPS yourself. And Cloud Run then starts your container on demand to handle requests and ensures that all incoming requests are handled by dynamically adding and removing containers. As an engineer, it's hard not to get excited about this, because this is a process that lets you focus on writing code and not on the infrastructure underneath. You will be like, here's my code, go ahead and deploy, run, and scale that for you. I don't want to know how, just do it right. So before I tell you everything about Cloud Run, I want to tell you a little bit about me. My name is Wietse Venema, and it's pronounced like this, we, like we go to the park, and then se, Wietse. I am a software engineer by trade, and I'm also a trainer at Binx. Binx is a cloud-native IT services company. We're strong in engineering, training, digital transformation, and we work with all public clouds, Google Cloud, Amazon, Azure, and Alibaba. But I specialized in Google Cloud, obviously. So I also like to draw diagrams to explain things. and I'm sharing those on my LinkedIn and Twitter. So feel free to connect with me or follow me. I'm from the Netherlands, which you could probably tell from my accent. And that also means that I own more than one bicycle. I have a cargo bike, a racing bike, a city bike, one that I take to the train station. I have a lot of bikes. And I put chocolate sprinkles on my bread for lunch, which people find weird, and I don't. Yeah, and one more thing. You might have recognized my name because I have a famous name twin. There is the Wietse Venema who wrote Postfix, like the software that used to power almost 90% of the internet's email. And he now works at Google, so he's the famous one. I'm just the one who wrote the O'Reilly book about Cloud Run, because this is my main professional accomplishment. And I wrote this book in the middle of 2020, in the middle of a pandemic, with my 2-year-old and my 4-year-old running around because the school's closed. Well, in practice, I wrote most of it at night when everybody was asleep. So, yeah, well, I'm a first-time author, and this has been an epic learning journey for me. And because the best thing is that people really like my book, and that's quite a relief if you've just spent 2 years creating something. And here's Kelsey Hightower, right? He is a well-known person in our community, and he even wrote the foreword to my book. And this means a lot to me because his leadership has been an inspiration to me and to many others in the tech community. And this is what he wrote. I've onboarded thousands of customers, and I wrote a framework to help Go developers build Cloud Run applications faster. And even I learned a thing or two from this book. What took me 3 years to learn, Wietse delivers in less than a dozen chapters. And as you can imagine, I'm super proud of this achievement. But what makes me even more excited is that people are actually now buying and using my book to do their jobs. And this is why I started writing in the first place. And they reach out to me to tell me, this is Simon, and he wrote me to say that he's looking forward to using my book as a reference. And Silvio, he wrote me from Spain and to tell me that his book has a real impact on his day-to-day job. And another thing I want to share with you, and this is the last one before the commercial is over, I promise, is that I'm now also working with Google Clouds to build their official Cloud Run course. And in a way, this very session you're in now is a sneak preview of the course, because the content in it is inspired by it. So coming out of this session today, you will understand how Cloud Run compares to other compute platforms on Google Cloud. And it will also help you understand what workloads might be a good fit and the ones that aren't. But first, let me know who you are and where you're from, so I have an idea who I've in front of me. So head over to that comment box. I think it's on that side. Yeah, on that side. Head over to that comment box and let me know where you're from, what do you do, and maybe something personal. The name of your cat. I don't know. I have 2 cats and two kids. I live in the middle of the Netherlands, by the way, Amersfoort. So tell me. I'm expecting a lot of people from Poland. My geographical knowledge of Poland isn't very good, so all those cities are super hard for me to place. It's to the east for me. Oh, we have one from Spain. That's cool. Yeah, I was in one session a while back, and then someone from Ivory Coast joined, and from Vietnam, and I thought that was like, and in the same session was someone from Sao Paulo in Brazil. I think that's one of the good things that COVID did to us, right? So that these events tend to be more global and that everybody has access. Awesome. I think I saw some familiar names as well. And be sure to share with us on Twitter or LinkedIn that you're in the session, because you get to win one of the copies of the book that we're raffling. Yeah. So after this short introduction, this is what you can expect for the rest of the talk. There are 3 sections with a short review, a summary, and then I'll reinforce the concepts I told you about by showing them to you with a demo. And finally, if you feel like it, you can stay for the hands-on lab. I think we're moving to a Google Meet, so we're not doing it in stream because it's not really interactive. And this lab, I've created it myself, and it's a series of challenges that get progressively harder, almost like a game. And you'll be using a temporary Google Cloud account. I've got you covered for that. So about questions, I would love it if you have a question, just type it into the comment box. I'm monitoring the comment box on my second screen here, and if I see something pop up and I can answer it in the spot, I would love to. So as soon as you think of a question, share it in the comment box, because it will be better than just watching a recording of this stream, right? In any case, if I will round up all the questions at the end. So bring your questions, please. That makes it a better experience for everyone. All right. Well, let's start with introducing you to or refreshing your knowledge of containers. So let's first start with the structure of a container image. A container image is a package with your application in it, along with everything your application needs to run. So for example, in a container image for a Java application, your application is packaged together with the appropriate Java virtual machine. If it's Node.js, the Node.js runtime is in there. So that might still sound a bit abstract, so let's zoom in a bit further. A good way to think about a container image is that it is an archive with files, a zip file, right? And those files include system libraries, executable programs, data files, such as in case of a web application, which we're deploying to Cloud Run, HTML files, images, CSS files, binary blobs. And if you use a interpreted language such as JavaScript or Python, your application source files might even be in there. So, and in the rest of this session, I'm talking about container images and containers, and both are different concepts. So let's make that clear once and for all. If you run a container image, that's a container. And what it actually means, if you run a container image, it means that you are executing one of the programs that are stored inside of the container image. So in case of the Java application, the program you execute is the Java virtual machine. So a container represents the running processes of your application. It only exists at runtime. If there's no running process, if there's no running app, there's no container. Got it? All right. So a running container has 2 other important characteristics. There are more, but these 2 are really important to help you make sense of this. First, the files from the container image are used to create a private file system for the container. So these are all the files your application will see. Second, your application has access to a virtual private network interface with a local IP. And what this means is that you can always open a port and listen for incoming connections. And that's exactly what Cloud Run expects your web application to do. It wants you to listen on port number 8080 to handle HTTP requests, or HTTP2 and gRPC. But it has to be that, right? So you can't, for instance, start an SMTP server and expect that to work. It needs to be HTTP, HTTP2, or gRPC. And this number, 8080, it's a configurable default. So if you don't want to listen on 8080 because, I don't know, you're running Rails and you want to use 3000, or you don't have the source files anymore and you just have the binary and it listens on port 80, you can change that. It's not set in stone, but it's the default. And you also don't need to provide HTTPS, right? Google's infrastructure handles that for you, and your traffic is always encrypted. Besides the requirement for an HTTP server that listens on the correct port, there's no restriction, right? Your binaries need to be compiled for Linux, but no Windows containers, sorry. But you can use any programming language using any binary dependency. If it runs in a container, it runs in Cloud Run. And that's super powerful because containers can run anywhere. Once you have your web application packaged in that container image, on Google Cloud, it can go to Compute Engine, to Cloud Run, to Kubernetes cluster, to a different vendor. And on your local machine, you can use Docker or Podman, which both are container runtimes. So before we move on, here's a quick summary. A container image is an archive with files. It includes executables, system libraries, data files, and more. A container is a running container image. It represents the running processes of your application. And a container image packages everything your application needs to run. So if it's a Node.js application, for example, your source code is in there and the Node.js runtime. And then Cloud Run expects your application to start on HTTP server, but your traffic is always encrypted on the Google network, and the public endpoint is HTTPS. So you don't have to manage SSL or TLS termination yourself. Now let's take a look on how to get your application to Cloud Run. When you deploy a container image for the first time, Cloud Run creates a service. And a service is a very broad and non-specific word, but it means something very specific in Cloud Run. And all of those specifics will become clear during this session. But the first thing to know is that a service has only one active container image. And the second thing to know is that every service has a public unique HTTPS endpoint, which is managed by Cloud Run. So Cloud Run receives incoming requests to that public endpoint, and to handle the requests, Cloud Run starts your container image on demand. And it makes sure to handle all incoming requests by starting more than one container if that's necessary. And that's something that's called autoscaling. I will come back to that later this session. Now, if you are familiar with Google Cloud, and I'm assuming you are because this is a talk for a GDG community, you're now probably wondering if you can also route requests from the global load balancer to a Cloud Run service. The answer to that question is yes, but in this session, I'm not diving deeper into that. But this will allow you to set up Cloud CDN, set up security policies using Cloud Armor, build multi-regional applications, use path-based routing to combine multiple backend services on one domain. So that's all possible, but obviously the global load balancer has a fixed fee attached and the default domains don't. And you can set up a custom domain, so you can register your own domain and point it to your Cloud Run service. Yeah, I want to pause here and direct your attention to that word service, because it's a key concept in Cloud Run. You create a service to deploy a container image, and every service has a unique name and an associated HTTPS endpoint. And as a developer, you will interact primarily with a service resource to perform your tasks. So deploying a new container image, rolling back to a previous deployed version, changing configuration settings like environment variables and scaling boundaries. You do that by interacting with the service resource. So on the one hand, at runtime, it's the thing that has the containers and serves the requests. And as a developer, you also interact with that service resource to push new versions or change configuration. Now let's take a step back and look at how that container image gets to Cloud Run, because you're not sending it directly to Cloud Run, but you send it through Artifact Registry. Cloud Run can only pull container images from Artifact Registry. So if you're used to hosting your container images somewhere else, keep in mind that with Cloud Run, you'll need to push them to Artifact Registry first. Hold on, what's Artifact Registry? It's a new service on Google Cloud. It's a fully managed service, and it was formerly known as Google Container Registry, or GCR. But Artifact Registry is more. It's a universal package manager. And you can use it to privately host container images, Node.js, Java, Python, and even Debian system packages. So to host your container images, you create a Docker repository. And Cloud Run can pull container images from that and then deploy. So let's take a look at how that works. So assuming you have your application packaged into that container image and you're ready to deploy it, you start by pushing the image to the Docker repository on the artifact registry. And a container is something, if you upload it, you push it, and if you download it, you pull it. New words for the same thing. And your container image will have a unique URL, an image URL in that repository. And you use that when you deploy to Cloud Run. So your container image is there. It has a unique image URL. And now you hand the container reference over to Cloud Run, which then pulls the image from artifact registry. So this is when you as a developer open your console, do G Cloud Run deploy, image URL is this, name of the service is that, and it starts deploying. You can also use the web console. And at this point, Cloud Run will pull the container image from the repository, and it will make a copy. It will make a local copy. Because Cloud Run wants to ensure that your service starts reliably and fast. And this internal container storage is fast. It's so fast that image size is not a limiter to container startup time. So if you have a 4 GB container image, it will load the file system just as fast as that statically compiled Go binary of 9 megabytes, right? And also, because Cloud Run copies the image, you won't get into trouble if you accidentally delete an already deployed container image from artifact registry. So Cloud Run makes a copy to ensure that it will work and that it performs well. Yeah, so I've just explained to you how to get your container image to Cloud Run through artifact registry. But I didn't even talk about how to turn your source code into a container image in the first place. For example, using a Docker file. And that's because that can be another talk entirely. Creating a secure, well-configured, and consistent container image, that can be quite hard. So what I want to say is that building an application is hard enough, let alone having to think about containerization. And for some use cases, on the other hand, for some use cases, using a container-based workflow is great because it gives you a great amount of transparency and flexibility. If you build the container image, you have the power to decide exactly what file ends up where, how it gets there, what user you use to run the application. But in some cases, the power is too much to handle. And sometimes you're just looking for a way to turn source code into an HTTPS endpoint. And you want your vendor to make sure that your container image is secure, well configured, and built in a consistent way. With Cloud Run, you can do both, right? So you can use a container-based workflow using the container image as a package that you push, and Cloud Run runs it for you. But you can also use a source-based workflow where you upload your source code, like think Cloud Functions or AWS Lambda. You upload the source code, and Cloud Run figures out how to turn that into a container image and deploys it for you. So in the demo, I will show you both approaches, and you can make up your mind and pick what's right for your use case. Now let's talk about auto-scaling and on-demand containers. What does that even mean? Cloud Run starts your container to handle incoming requests, and multiple requests can be handled by a container at the same time, concurrently. As long as the container is handling requests, Cloud Run will not shut it down. So unless something bad happens, like an application crash, right? So most of the time, if you have a service with low load, one container will be running and it will be handling requests for you, right? It's almost like a server. Now Cloud Run automatically increases capacity when necessary to make sure it handles all incoming requests. And this is how that works. Every service has an internal HTTP load balancer. And that load balancer distributes requests over the group of available containers. If all the containers are busy, Cloud Run starts adding additional containers to the service. But as soon as demand decreases again, Cloud Run stops sending traffic to some containers and shuts them down. So there's an upper limit to this. The number of container instances in a Cloud Run service is limited to 1,000 instances by default. And if you need more, you can submit a request for a quota increase. However, over 1,000 containers can unleash a lot of load on downstream systems and APIs, such as, for example, your relational database. And they might not be able to handle that, right? So you will find yourself lowering the limit more often than increasing it to safeguard the stability of your system. Now, and this is when it gets interesting, right? When no requests come to the service for a while, Cloud Run also selects that last container and shuts it down. And then a fresh container will start on demand as soon as a new request comes in. You might also know this as scale to zero. And so your first reaction might be, this process is very attractive for economic reasons, because this means I'm not paying for idling containers. But that's not the whole story, because the pricing model of Cloud Run is unique, as you only pay for the system resources you use while a container is handling a request with a granularity of 100 milliseconds. And obviously, when your application is starting or shutting down, you're also charged. And I want to emphasize here that you are charged for container time, not request time. So if you have that single container running and it can handle 50 or 200 requests at the same time, you're not paying 200 times for the same system resources, but just once for the container time. The price of a container, it increases with CPU and memory, so you can allocate containers with up to 4 CPUs, 8 gigs of memory. But that will be more expensive. So most of the other compute products, this is the serverless part, right? Because most of the other compute products, they charge for servers as long as they are running. And even if you're not using them to handle requests. So that means you're often paying for idle server capacity. But now that nothing comes for free, right? So now that you know how the pricing model of Cloud Run works, it won't be a surprise that the lifetime of a container on Cloud Run is only guaranteed while it's handling requests. So if it's not handling any requests, Cloud Run can shut it down. That doesn't mean it will, but it might. In fact, the containers live much longer than you would expect if they're not handling requests. And that's because as soon as a container is handling no requests, the CPU is throttled to nearly zero. And this means that your application will run at a really slow pace. Say hi to the little tortoise there, right? So as soon as your container is not handling requests, that throttle tortoise comes and it sits right on top of your CPU to slow it down. You can't do any meaningful work, and you can't make network requests to third parties while your container is not handling requests. And this is where Cloud Run gets different from having a traditional web application, right? Because Cloud Run shuts down and throttles idle containers, you should complete all work before you return an HTTP request. And this is why, because that very request might be the last one to be handled on the container. And as soon as the container isn't handling requests, it will run very slow and potentially be stopped. So this is what's confusing to people often, because I'm not saying now that you can't use background threads, right? If you use non-blocking I/O and you do all the work in a background thread, that's okay. But just make sure to finish all processing before you return the request to the user. The solution here is to redesign your application and run background tasks on a different service, for instance. So that's one way to solve it. You can turn your background task into an HTTP request, and you can integrate. You can use PubSub or Cloud Tasks. So you will go to Cloud PubSub and say, "Hey PubSub, can you send this HTTP request to that other Cloud Run service for me?" And retry it if it fails, and also wait for completion, please. And then you can go. Your application can continue, return the request to the user, and then that background processing will happen on a different Cloud Run service. That works with HTTP push subscriptions. I've made a great diagram about HTTP push subscriptions and how this can work. Follow me on LinkedIn, then it will pop up. So there's another consequence to this concept of disposable containers. You don't have any control about when they start and where and when they stop. And that has an impact on data, right? So on a traditional server, you have a disk there. It's big, and you can store data directly on the server instance itself. On Cloud Run, that's not possible. So while the disposable containers on Cloud Run still have a small disk you can write to, the entire file system is in memory, right? So the biggest disk you can have is 8 gigabytes, and if you write to that, the available memory decreases, right? So if you write a file of 2 gigabytes, you have 2 gigabytes less of working memory. So that means that you will need to store persistent data in a downstream system. And we have been doing this to scale applications, right? So you decouple compute and storage. So you store binary data in cloud storage. Session data goes to Redis, which is called memory store in Google Cloud. Your application data goes to relational database, just like you used to. The key thing to remember here is that while you can write data to disk, you should be prepared to lose it. But feel free to store cache data there. If you're using PHP, you can write your op cache there. But if you want to keep it, save it downstream. So, and then I want to talk about portability, because portability is a valid concern for most application developers. And here's a couple of reasons why. Maybe you need to run your application in a geographical region where Google Cloud has no physical presence. There's no data center there. And maybe you're also required by legal reasons to run it there. I don't know, data sovereignty rules, for instance. But maybe you're just afraid of vendor tie-in, right? You want to have the freedom to switch to another vendor with low switching costs. In any case, applications on Cloud Run are portable in 2 ways. So Cloud Run reuses containers. You already learned that containers can run anywhere. So that makes your application inherently portable. But also the platform Cloud Run, it's API compatible with Knative. And that's an open source add-on you can install on top of Kubernetes. Now, this is what confuses people a lot. So I'll take care to explain this. Knative, it's an open source project. It has an API to deploy applications, and it has behavior, right? It's also it scales your container based on requests, and it scales them down to 0. So that's the platform. It's an entirely different implementation than Cloud Run has, but the API is the same, right? So this means you can take your Cloud Run app to Knative on Kubernetes and get the same runtime behavior and the same API, but it's a different implementation. The Cloud Run is a proprietary product. You don't have the source code, but it behaves in the same way as Knative. They have the same runtime contract. So there's one side note to make in this whole portability on the portability subject. If your application depends on proprietary services on Google Cloud, and I'm thinking now of BigQuery and Firestore, for example, those are databases that don't have an open source alternative. So you will have a harder time migrating your app out of Google Cloud. Well, to summarize, you learned about container images and how they are a package of your application and everything it needs. Your application can be written in any language, using any library and any binary. Cloud Run takes a container image, turns it into an HTTPS endpoint, and all it expects is your application to listen to port 8080 and respond to requests. Now, to deploy your container image, you create a service resource. And as a developer, you'll interact primarily with the service resource to perform your tasks, such as deploying a new version, rolling back to a previously deployed version, and changing configuration settings like environment variables and scaling boundaries. And finally, the pricing model of Cloud Run is serverless. It's unique, right? You are charged for container time while handling requests. But a consequence of this model is that you can't rely on running background tasks on a container, because if you start a background task during a request, and that request is the last request to be handled on that container, it might be idle, throttled, and gone, right? So run your background tasks on a different Cloud Run service and use a message queue in between to decouple them. So with that, it's time for the demo. There's no questions still, so bring your questions, please. That makes it better. Yes, demo. So I have a small application here locally. It's a Go app. I can show you the code. It's basically an HTML endpoint, an HTML template that displays a few values. Well, let's run it locally. Go run, name it Go. I allow, and I refresh. So there we go. This is my web application, and it tells a bit of something about my environment, right? So there's the amount of memory on my laptop, the uptime, the request headers, and there's a big red button. And if I click this, it will send a REST request to the server, and it will stop the server. And then after a second, it refreshes the page, and you'll see that the application is gone. Boom, it's gone. So if we do that on Cloud Run, it shouldn't matter, right? It should just be a new instance will pop up. That's the ID. So, but locally, obviously, the process is gone. There's nothing there. So now let's get that application to Cloud Run, right? So the first thing, I see a question coming from the differences between Cloud Run, App Engine, and App Engine Flex and GKE. So Cloud Run, the containers on Cloud Run run directly on top of Borg, which is the globally scaling container orchestration thing that Google uses to run all their services, right? So Compute Engine is built on top of Borg. Cloud Run is built on top of Borg. Kubernetes Engine is made up of Compute Engine virtual machines, right? So there's a few layers of abstraction in between. Now, App Engine, Cloud Functions, and Cloud Run are built on top. They use the same platform underneath. So they are very comparable. And in fact, if you take a Cloud Run service and you set concurrency to 1, so you can make sure that a container instance can only handle one request at the same time, that's basically a Cloud Function. So I hope that answers the question. And GKE is managed Kubernetes, right? So that's a different thing. I hope that clears it up. So to deploy my application to Google Cloud Run, I will need to create that Docker repository and artifact registry first. So here we go. I will do gcloud artifacts, and then gcloud helpfully tells me what I can do next. So I want to do something with a repositories. There we go. I can create one. Yes, I want to create one. And then it wants me to give a location and a repository format, which is Docker, and a name. Okay, create location US, repository format Docker, and then I will call it Cloud Run demo. Okay, so there we go. I have a private Docker repository on Artifact Registry in the US region. There's another question. What are typical scenarios to use Google Cloud Run? Yes, if you have an application that handles HTTP requests. So I don't know, serving machine learning model predictions. Your CRUD app that handles that's just a web application. If you want to process events from cloud storage and run some processing, also a good use case for Cloud Run. That's the question Jude asked. I have a repository created. It's a Docker repository. And next is turning my local source code into a container image. And I'm using Docker for that, right? So there's a Docker file here, and it describes, it's basically a small script that describes what to do with the source code to turn it into a container image. So what it does, it mounts the source directory, it downloads dependencies, it then builds the binary, then moves to a distroless container image that's more useful to run applications with. And then it copies in the binary and sets the entry points. That's the configuration to run that binary. Now, to build that container, I will use Docker, but then I will need to tag it with the image URL I'm going to use. So I will start with putting my Google Cloud project into an environment variable. So gcloud config get value project. So this is a subshell here. This will put the output of gcloud config get value project, which is my project name, into the project environment variable. And a Google project is how every cloud resource you create has to be inside of a project. That's how you organize your resources in Google Cloud. The image URL has the project ID in it, so it will be us.docker.pkg.dev, US because I use the US location, docker.pkg.dev because that's artifact registry, then the project, and then the repository I created, which was Cloud Run demo, and then the name of my container, hello. There we go. So now I can build my container image with Docker. Docker build tag this image, and then using the Docker file. Yes, I need to pass the source as well. So here the dots, that's the current directory. That's the build context, and Docker file runs the Docker file inside the directory, more or less. So that was fast. That's because it uses cache. Before I started with the session, I did the build to make sure that this was fast. Okay, so I have the container image locally. I'll need to push it to the Docker repository and artifact registry now. But first, I will need to teach Docker how to authenticate to Google Cloud. Now, you need to do this only once on every machine. So, and gcloud has a little helper script to make that happen for you. So you say gcloud auth configure Docker. So I'm telling gcloud to configure Docker for me to use when I push to this domain, use docker.pkg.dev to use gcloud to authenticate. And I have already done this. But now it works. I can do Docker push now. Let's do that. Docker push. There it goes. Now, while that's uploading, yeah, so now I can, this is the moment, I can deploy my service, right? gcloud run. Gcloud run tells me, lets me list regions. It tells me something about the revisions, services, and there's a deploy command. So that sounds useful. Gcloud deploy, run deploy. And now I need to specify an image URL. I can, because that's the one I use to build it. Image. I will need to give it a name, so I'll do hello world. And I also want it to be publicly accessible, so I will say allow unauthenticated traffic. And I guess that's the first time I typed unauthenticated without arrows in a demo. Yes. Well, there we go. It's there. I got an HTTPS URL. Is it that easy? It's that easy. Bring up that. So now my service looks a little bit different because it detects that it runs on Google Cloud and it tells me more. So so the uptime is now 14 seconds. The memory I have available is 265 megs. Remember, you can increase that to up to 8 gigabytes and 4 vCPUs. So the region I'm running in is US Central 1. This is the default Compute Engine service account, which is a bad practice. Never do that in production. There is an instance ID. So, and this will change, right? So if I do a refresh now, it's the same, right? Uptime is 50 seconds now. But if I stop this instance, boom, a new instance. And I'm changing the color of the box based on the hash of the instance. So now you also see that when I stop it, the next uptime will be 0 seconds. So if I refresh, the uptime is 14 seconds. If I stop the process, it tells me, well, that's the first request that was handled in this instance. The uptime is 0 seconds. There's a few environment variables here. So the environment variables that are prefixed with k underscore come from Cloud Run. So Cloud Run tells me, well, this is the first version that you deployed, and this is the name. Well, that's all right. Some request headers. Yeah, so you see something about the trace context here, for instance. That's something that the Google Cloud Infrastructure adds. So what am I going to do here? Yeah. So about so I've sent I don't know maybe 4 or 5 HTTP requests to this service now, and the uptime is 49 seconds, right? So so I've paid only for the request time. 5 requests, that's 500 milliseconds in total, right? Because it's rounded up to 100 milliseconds. So I've paid for the compute time that was used for 500 milliseconds, but the instance was running for 50 seconds already. So if I refresh, it's 1 minute and 20 seconds, right? And now I've only paid for 600 milliseconds. So that's economical. There's a question. Yes. So when I stop the process and a new instance is created, Cloud Run starts a different container for you. Yes, that's correct. Well, why did I use image twice? Yeah. So there were 2 steps, right? I built the container image. So I have source code on my laptop. I need to turn it into a container image. So I do Docker build with the image URL. And then I have the container image locally on my laptop, and then I do a gcloud run deploy with I push it to artifact registry, and then I deploy it. So I hope that answers your question. Yeah, so let's reinforce that. Let's take a look at the how it looks like when I make a change. So then I will walk you through everything again. I will change the title of the page, and I will say hello GDG Poland. Exclamation. So what I need to do now is I've made a change locally. I will need to do a Docker build locally again. And I will need to push it, and I will need to do a gcloud run deploy again. So I'm now building container images on my local machine, but you can build it somewhere else, right? You can use Cloud Build on Google Cloud, or your CI system. Just make sure to push it to artifact registry when you have that container image. That's what I'm going to do next. If this helps. So push again. Build the image, push the image. Waiting for the push, and then deploy it again. So I could have used gcloud run services update and then change force the image to a different tag, but this works as well. Yeah, Konrad, Cloud Run can also run on Athos. That will be the managed native version, right? So there's Cloud Run, the proprietary version, and that's the one I'm using now. It runs on top of Borg. It's super fast and scales very well. And then there is the managed native version that runs on top of GKE, and that's right, that runs on top of AWS, Azure, Bare Metal. So I deployed the thing. I refresh, and there it is. Hello, GDG Poland. Yes, a good question, great question about GKE Autopilot. I didn't investigate Autopilot, but what I got from it is that you pay only for the pod time, so it's not request-based. And it's still Kubernetes, so you get to use the entire Kubernetes ecosystem. So that's actually a great offering. But I don't have anything else to tell. I still need to figure out how that works. Maybe in a follow-up session. So I promised to show the source-based workflow as well, because like maybe container images get your head spinning, or maybe you just want the convenience of not worrying about Docker files. So let's start with deleting the Docker file. Remove Docker file. There it goes. It's gone. There's no Docker file anymore. I'll change the title again. Look, no Docker file. And then I will do gcloud beta, because it's still in beta, but it will be GA probably soon. Run deploy, and this is the same, right? Hello world, the name of the service. But it will say source is this folder, right? See the dot there? Now Cloud Run will take my source directory and figure out what to do with it. It will take a look and and we'll take a look at the source code, and in this case, it will see a go.mod file there. So it will figure out, well, this is a Go app. Let's do Go build and put that binary into a container image. But if it sees a package.json file, it will think, hey, that's a Node.js app. I will do npm install and then download a million Node modules and put that into a container image with the Node.js runtime, and there it is. If it sees a pom.xml, it thinks this is a Java application. I will do Maven or Gradle install, but Maven, I can't remember the command anymore. But and then package that into a container with the Java virtual machine. It also means that it takes a little bit longer, right? This workflow. So that's what I like about when I'm developing. I like the container-based workflow because it's only pushing the changes. It can be pretty fast, but this takes a while because I have to upload the source. Then Cloud Build will start building the image behind the scenes. It can't use a cache, so it takes a little longer. But then no Docker file to worry about. So that's good. So it's there again without the Docker file. I can refresh. Look, no Docker file. Well, that's a good thing. How are we on time? I'm closing to the 12-hour mark, so I think this is it. Yes. This is the demo. We can, yes, Konrad. There you are. I'll stop sharing my screen.
Yeah, I was trying to comment as well on a couple of things. Just realized I wasn't on the stream, which is good because I wasn't actually
talking over me.
interrupting. Yeah, no, nothing bad there. Awesome presentation. I liked it a lot, especially the insights about how Cloud Run works. I think this is really missing sometimes in the documentation and seeing how you can get this running. I do actually.
Thanks.
If we have 4 minutes left, yeah. I actually do have a question or maybe comments on the Cloud Run development. So I'm not sure, we actually had a session on the scaffold and Cloud Code. Those are pretty cool tools, right? So you can actually write your code and directly from the V code, you can actually push this container, generate it, and actually you can run it both on your laptop, right? So there is a Cloud Run emulator. Yeah. And you can also push it to Google Cloud, right? So it's even it's what you were showing is great because it shows how actually Cloud Run works, how you build those containers, etc. But once you have this understanding, if you need to develop an application, I guess you would go for scaffold itself, or you would just use Cloud Code to do this. I would call it continuous development to have the previews, right?
Yeah, you're correct. Yeah. That will be a great additional slide to this presentation.
Yeah, but this is really good because it shows how it actually works. I'm trying to see if there are any more questions there, but I think all of those were addressed. One comment actually on the App Engine and Cloud Run, right? Is it me, or I have the feeling that actually Google is trying to move all the services that they have. They're trying to make it available on Kubernetes, right? So they're kind of portable. So App Engine is a great example. When it started, Google Cloud started with App Engine, right? And now we have Cloud Run, which has similar capabilities. Yeah, I think it's getting even more powerful with the continuous delivery features that it gets, all the things you can tweak in it. And I think that's the approach, right? If you look also at the Kubeflow, which is now delivered as AI pipelines, etc., right? So I think even though people may think there is a step back because they don't get all the features that they have with App Engine or other services, in the end, for me, it means that you can actually move your workloads to Kubernetes, to cloud native, right? And you can move them everywhere. So when you deploy Anthos on-prem, AWS, Azure, you're getting all your GCP services, which is pretty cool. And I don't see this being done by other clouds.
Yeah, that's the strategy, right? They want to be open, and I think that works. I mean, they are obviously they don't have a lot of market share, right? So this is a great strategy to get more market share. So we have no lock-in. You're free to leave, but our infrastructure is great. So and at least you know what's going on. You can inspect, you can see.
Yeah, exactly. So let's see. I don't see any more questions. I think they will arise probably during the. So guys, I really hope everyone got the link because we sent over this through the email. And actually, Wietse, I updated the link because I put the wrong one. Can you just check if you have the access to the Meet invite? It should be on your email. I canceled the old one and just added the new one.
Let me see. That's what so that's the Meet link. Yeah, I see that.
Yes, exactly. The other one was for other communicator. Okay, awesome. So thanks a lot, guys, and see you in the labs in around a minute or two.
Cool.
Okay, so I'll
see you there.
Streaming and we'll see you there.
Thanks. See you soon. Bye.